Welcome everyone to this video. So today we are going to start with a new chapter called Taare Zameen Par. I'm sure everybody would have seen that movie, but that movie is actually not about Taare on Earth. Um, it's actually a movie about something else. So what is actually Taare Zameen Par? Taare Zameen Par is nuclear fission and fusion. That's what stars are, right? Stars are those hydrogen and helium nuclei which are fusing together. They have fission, and those fission and fusion reactions they create a lot of energy, which is actually the reason of existence of life. The mass in those nuclei is converted at a really fast pace in microseconds into energy. You can see the sun is slowly consuming itself to give us energy by the uh, process of nuclear fusion. It achieves that. So, what is actually a nucleus? Let us begin. The nucleus. So, the first thing which we come to know about nucleus is that it has two main elementary particles. Uh, that is protons and neutrons. So if I add the number of protons and neutrons in the nucleus, I get atomic mass number. Atomic mass number, it is represented by A, and it is equal to the sum of number of protons and number of neutrons. So let us take case of carbon because it is like the most common element on organic life forms. Um, Carbon has 6 protons and 6 neutrons. So what would be the atomic mass number? For carbon, we will say mass number is equal to 6, that is number of protons, plus 6, number of neutrons, that is 12. So it may seem that there is some kind of symmetry between the number of protons and number of neutrons in all the nuclei which exist in uh, the universe and the world around us. And that is true. There is a lot of symmetry between number of protons and number of neutrons. In a lot of nuclei, these two numbers are basically equal. So that is something which we can take note of. But it's not always, it's not a rule that the number of protons and number of neutrons are always equal. Sometimes number of neutrons are more than the number of protons. Like take the case of uranium. It is which is producing nuclear fission in the nuclear reactors around the world, besides polonium and other elements, the uranium has an atomic mass number of 235 and it has number of protons only 92. So clearly the number of neutrons is much greater than the number of protons. So it's pretty fascinating when we think about the Taare on Zameen. As you can see, there are some stars which have a life of a billion years. Some stars have a life of million years. So the transition from one phase to another at different times. And by transitioning, I mean they become from those newborn stars to those big giant form stars by the process of nuclear fusion and combination of all the elements. And so, what is actually the size of a nucleus? Let's say if you want to bring a Tara on Zameen, right? So we would have to know that how much big that Tara is and what is actually a Tara. It is made up of nuclei only. So the size of the nucleus, it's spherical, is given by this R naught into a to the power 1 by 3. This value R naught is 1.2 into 10 to the power minus 15 meters. This A we have already studied. This is atomic mass number. So that means the bigger the number of nucleons inside a nuclei, uh, the greater its size is. So to end this uh, the movie review, we want to do a question. Question is, iron uh, is an element which is the most common metal on Earth, and every day we uh, are basically living our lives uh, on the basis of discovery of this unique element. So, what is the isotope of iron? Isotope means those forms of the same atom which have the same protons as the one which we are considering, but different number of neutrons. It's pretty fascinating how atoms are of different types on the basis of their nucleus. So the most common form of iron atoms in the universe is the one with atom 56, atomic mass 56. Our question is, if R naught is given as 1.2 into 10 to the power minus 15 meters and the atomic mass unit of iron is given as a 1.66 into 10 to the power minus 27 kg. Then what is A, the radii of an atom nucleus? B, uh, approximate mass, and approximate density. Because eventually this is the most stable nuclei, and we all know we are looking for stability in our lives. So what is the radius? Radius would be 1.2 meters into 56 to the power 1 by 3. Right, because that was our formula. So it is given to us as that 56 to the power 1 by 3 is some 3.82. So we can multiply. So we'll get some value for 6. As the radius. What would be the mass of the iron nucleus? We'll say that one unified mass is 1u. So we multiply one unified mass with the atomic mass number of that particular nuclei to get the total mass. For example, uh, when we are hammering something, we do not know the hammer is made up of iron, right? So many people in our lives, they are just hammering away at things. The man with the hammer. So what is the mass of the atom inside that hammer? We are calculating that. So it is 56 into 1.66 into 10 to the power minus 27 kg. You know, the man with the hammer is considered the strongest man in our culture, because if you can hammer something, you can hammer everything. And what is that hammer made of? Iron. 56 into 1.66. If you want to become strong, just start hammering at things. Take a hammer and start hammering. You will become strong. So what do you say, Mr. Hammer? What will be the mass of a single atom inside that hammer, it would be 9.3 into 10 to the power minus 26 kg. It's pretty simple calculation. Our next objective is to find the density of the mass of the nucleus of that hammer, right? The phone on which you are seeing this laptop, uh, everything is made up of iron. So what is the nuclear density of that iron atom that we want to figure out? So nuclear density, so its value would be some whatever mass we calculated. It was some 9 point something, 9.3 into 10 to the power minus 26, and divided by the volume of a nucleus, 4 by 3 pi r cube. You know, mixie grinder also has those sharp ends, which is made up of steel. So what is so special about uh,